Okay, Honors Algebra 2, notes on Chapter 2, Section 6, continued with families of functions, absolute value, and graphs. We talked about how we had shifting up, down, left, right. Now we're going to talk about stretching and shrinking. So a vertical stretch multiplies all y values by the same factor greater than 1. And when you shrink a graph, it's going to reduce the y values by a factor between 0 and 1. And the reason that happens is because you're multiplying by a fraction. A reflection in the x-axis changes the y values to their opposites. And so it reflects, it flips over the x-axis. The graph flips or reflects over the x-axis, just like I said. Recall the parent function, y equals the absolute value of x. So this, you should be able to graph quite easily without having to think of the points, because it's 0, 0, 1, 1, 2, 2, 3, 3. It's the points on the diagonal. And then, of course, over here, on the negative side of x, the y's will still be positive because the absolute value of any value is always positive. So that's our parent function. Now, in this table on our note sheet, we're going to talk about what these mean here, like this 4, this 1/2, and then this -5. Of course, this one here, y is equal to the opposite of the absolute value of x. That's our reflection, so the translation here is called a reflection. And what the graph is simply going to do is flip over on the x-axis. When you multiply it by some number, you're stretching the graph. So in this case, our description here is we're going to multiply by 4. And it's going to stretch the graph. This, we're going to cut all the y values in half. This one here, you're going to multiply all the y values by 4. This one, you're going to multiply all the y values by half. That's called a shrink. This, we're doing two things, really. The leading negative out here is going to flip it upside down. And then we're going to multiply all the y values by 5. Not the x values, the y values. See, because this is y equals negative, so we're going to be upside down. It's going to be a negative y value. And then multiply by 5. And whatever the absolute value of x is going to be a positive number. But times that negative number is going to flip it upside down. So it's going to flip and multiply y's by 5. So this is called a reflect and stretch. And then at some point in this lesson, we're going to see how we put the stretching and the shrinking in along with the vertical and horizontal shifting. So our first example here, this is simply our upside down graph, this negative out front. Okay, so when it's a leading negative, it's going to flip it upside down. Upside down. Why? Because the y's are opposites. Right? All the x's on the one side are going to be positive. I could stick a negative x in here, but the absolute value of a negative x is going to be a positive x anyway. But then this says, hey, keep it negative. So the y values are opposites. So what I sometimes like to do, excuse me, is just put dots. I don't connect the dots on the parent function, but I like to know where the parent function is. And then I'm going to show my flip. None of these points are moving because I don't have any vertical or horizontal shifting going on. And so it's just the absolute value graph flipped upside down. No, and we can check it. We could say, okay, well, what if I pick an x value of 1? What's the absolute value of 1? Well, the absolute value of 1 is 1, but when I make it negative, I'm down here at negative 1. Absolute value of 1, 2 is 2, but wait a minute, I have to be upside down. So there I am upside down. Okay, once you get the hang of it and you know that this leader on the outside makes it flip upside down, it shouldn't be too bad. All right, you could also think of these leaders out here in the front, these stretches and shrinks, as slope. But that only works with the absolute value graphs. We will later on in the year do some shifting with parabolas, but for now it's absolute value, and because the absolute value is really two linear functions together, it's called a piecewise function. You can think of this as slope. Okay, so if this was my slope, there's a 1 here, right? So, excuse me. I would go from the 0, 0, I go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Okay, so that's my slope. And then this is a mirror image, the absolute value graph. All right, side 2. Graph, again, y is equal to the opposite of the absolute value of x. Now, with these graphs, you don't have axes, so you have to draw them in. And you should draw the axes so it goes off of the grid if you're given a grid such as this. Also, remember when you are graphing on regular graph papers such as this that doesn't have the axes on it already, you need to give, a y scale. Here my scale is ones. Okay, so I'm going by ones on both x and y. So again, I'm going to graph just with dots my parent function. And then I'm going to show the reflecting across the x-axis for my other points on this graph. So if there's something you're not understanding that I'm talking about in the lesson videos, please ask a question in class. My groups of Honors Algebra 2 students are a little bit too quiet. All right, now notice here, let's fill in the box. This is a reflection across x-axis. Now notice this, if we think of this as slope, this is pretty steep, so this right side of the absolute value function is going to rise up pretty quick. So I'm going to want to make my x-axis pretty low on this grid because I don't need much on the negative side. Because if you notice, the 4 is positive, it's not negative. So I'm going to be up here on the positive y's. Okay, so it makes sense to me to make my axes low, my x-axis low. Okay, of course this is the x-axis, this is the y-axis, y and x. My scale is ones. Now, sometimes you'll scale a grid like, x's by ones and y's by twos or y's by fives. And then you would say that on your scale definition. But when I say ones, I mean both x and y. Okay, so this 4 is a stretch, and you can think of it as a slope. Like 4 over 1 from the point 0, 0. Okay? The 0, 0 is not moving. I'm going to just dot in my parent function. And again, I would like you to do this in your homework and on any assessments. Okay, parent function's got to be there. If you have highlighters, that will work for your test or in your homework. Now, we're going to stretch this graph by a unit 4. And remember, it's the y values that are going to be stretched, right? Y equals 4 times something. Okay, the absolute value of 1 is 1, but wait a minute, I have to multiply it by 4. So 1 times 4 is 4. So when x is 1, y is 1, 2, 3, 4. When x is 2, absolute value of 2 is 2 times 4 is 8. So this is 4, 5, 6, 7, 8. Now, if I wanted to use this idea of slope, well, from the 0, 0, I would rise 1, 2, 3, 4, and run 1. And again, 1, 2, 3, 4, and run 1. So it works. And because the absolute value function is a mirror image, if I'm 1 unit away from the y-axis on the right side, then I would be 1 unit away on the left side as well. This one I'm 2 units, so I go 2 units on the other side. And now I can draw my stretched absolute value graph. Okay, you see the arms of the graph, they get closer together. Pulling it and you're stretching it up. So let's fill in the box. What happened here? Well, stretches by a factor of 4. Hopefully you're not finding this too terribly difficult to understand. But if you do, post a question on the homework discussion or ask me a question in class. Now our next example on the bottom left here is a shrink because we see this 1/3. That's a fraction. That's a number between 0 and 1. So it's going to shrink the graph. So first I have to draw my axes. I don't have to be up too high because there's nothing negative. None of the y's are going to be negative. There's my x-axis. Not drawing very straight lines today. There's my y-axis. This is y. That's x. My scale is 1 again. I'm going to draw my parent function, just with dots so I know where it is. Okay. Now, you could think of this as slope again just on the right side, okay, and then you use the corresponding points on the right side to the left side. So from 0, 0, you're going to use slope. So it's going to be up 1, and then to the right 3. Not a negative slope. See, this got a positive slope. The other side, the absolute value, of course that has a negative slope, but it's the mirror image. Like if you would take your paper and fold it in half, this point would lie on top of that point, this one on top of that one. You know, if you look here, this point is 1, 2, 3 units away from the y-axis. Its corresponding point would be 1, 2, 3 units away on the other side. So let's graph this. Remember, I have to shrink the y values by 1/3. Okay, so on the parent function, the y value is 1, but a third of 1 is a third. And a third of 2 is 2/3. And a third of 3 is 1. Okay, so the 0.31 is on this graph. It makes sense to choose x values that are divisible by 3. So the next x value would be 6. 1, 2, 3, 4, 5, 6. Okay, and then a third of 6 is 2. And so I get this nice flattened out graph. Okay, so let's look at this point. I'm gonna talk about the slope in a minute. But let's look at this point. It's 3 units away, so if I was 1, 2, 3 units away on the other side, that would be the corresponding point. And then this point is 6 units away. Remember, we chose an x value of 6. So I'd be over here at -6 and up here at 2. These are corresponding points. These are corresponding points. And now I'm going to draw the ray that comes out on that side. Now let's check it for slope from 0, 0. If I would rise 1 and run to the right 1, 2, 3, there's that point. Rise 1, run 1, 2, 3, there's that point. What do we do here? Well, the graph shrinks by a factor of 1/3. Shrinks by a factor of 1/3. The next one we'll graph it thinking about the stretch, because it is a stretch. If you look here, the 3 would be a stretch. The negative means upside down. So the 3 being a stretch, and we're going to be upside down, I'm going to move my x-axis up a little bit higher. Okay. So I'm going to put my x-axis, I don't know, somewhere like here. And my y-axis somewhere in the middle. Now remember, for all graphs in your homework, you must use graph paper. I have some on the desk that's in front of my desk. So make sure you put some of that in your notebook. Okay. Parent function would be 0, 0. And all the points on the diagonal, 1, 1, 2, 2, 3, 3. And then here we have on the opposite side. That's the parent function. This negative right here means reflect. This is my y-axis and my scale is 1s again. My scale over here was 1s. This is my x-axis. All right, that negative out front is my reflecting. This is my stretch. And when you stretch a graph, the arms of the graph are going to come closer together. And this part right here, if you remember from the last lesson, I'm moving that somewhere. Now, inside with x, move on x in the direction opposite the sign. So I'm not moving it to the right. I'm actually moving this to the left. So this means left 2 units. Okay, so I have to find what I call the new 0, 0 point. You know, everything in the front I do last. So I'm like, all right, well, the 0, 0 is going to move left 2 units. So I'm going to take the 0, 0 and move it left 2 units. I know I have to be upside down. Not only that, my slope is -3, right? So from this, I would fall 3, 1, 2, 3, and run to the right 1 unit. Again, fall 1, 2, 3 to the right 1. You could do it yet again, 1, 2, 3 to the right 1. Now this line right here, this vertical line, is like my axis of symmetry. okay? So if this point is 1 unit to the right, then its corresponding point would be 1 to the left. And again, here's my line, here's my reference line, my axis of symmetry. If I'm 2 units on the right side, I would be 2 units on the left side. And this one was 3 units, okay? Follow it down. 1, 2, 3 units, so I'd have to be 1, 2, 3 units on the left. And there's my upside down graph, thinking of it in terms of slope. I'll do the philosophical reasoning with you to show that the points do match up. So if x is negative 2, right, if x is negative 2, negative 2 plus 2 is 0, absolute value of 0 is 0, multiplied with this is still 0, so that point works. Okay, but I didn't have to go through all that and think of all these points in my mind if I knew that I just moved the 0, 0, left 2 units. And then I used the slope for this. Well, let's just continue. If x is negative 1, right, because this point right here has an x value of negative 1. If x is negative 1, then this becomes positive 1 inside. Absolute value of positive 1 is 1. Times negative 3 is negative 3. So when x is negative 1, y is 1 to negative 3. Okay, so the point does match up. This is just a quicker way of graphing these functions. Okay, so what did we do? There was a reflection. There was a stretch. And there was a horizontal shift. Okay, we reflect on the x-axis. We stretch by 3. And we shifted to the left. And again, you can check those ordered pairs after you draw the graph to see if you're correct. Now on a test or quiz for these, you're not going to be able to use a graphing utility. You're going to have to graph these by hand. Okay, so you won't be able to use Desmos or anything like that on your test or quiz. So if you have questions, please ask. All right. These examples are just, a couple more examples for us to get used to doing this. You might want to pause the video and see if you could do this example on your own. I am going to notice the axes are drawn for us. The scale is there, so we don't have to do that business. It's telling me that this is the x-axis and that this one is the y-axis, so we're good with that. Let's look at the example. Y equals, oops, I got to reflect, so I'm upside down. This means move not left 3, but to the right, and up 2. Lots of times students get these mixed up. Just remember the little phrase. Inside with x, you move on the x-axis. That's left-right, okay? Outside, away from x, you're moving actually up or down on the y-axis in the direction of the sign. All right, parent function, just put my little dots. That is the regular old parent function. This says, take the 0, I'm going to do this part last because this is my slope and my slope is negative 1. And remember, you use the slope on the right side and then you look for corresponding points when you're done. So this says take the 0, 0 and move it to the right 3 units and then up 2. So I'm going to move it to the right 3 units and then up 2. Now I can use my slope. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. There's no stretching or shrinking. So these corresponding points are not going to be that difficult to find and figure out. Again, you could take some of these ordered pairs that we graphed on our transformed function and test them in the original equation to make sure that you have it right. Hopefully you're finding that these are pretty easy. All right, what do we got in the next example? Well, I have a stretch. I'm moving not to the right, to the left, and then this says move down. So it's good to know and to draw the parent function so that you know where the 0, 0 is. Okay, these two are going to move that 0, 0, that vertex point. And then you use this as a slope to help you find the other points. Okay, so I'm moving to the left 3 and down 2. To the left 1, 2, 3, and down 2. And now I'm going to use the slope. Notice I'm not reflecting, so my absolute value V-shaped graph should be going upwards. So from this point, I'm going to move up 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 to the right 1. Here's my reference or my axis of symmetry. If I'm to the right 1 here, I got to be to the left 1. And if I'm to the right 2, I've got to be on the left side here, 2 units. And then I connect my points. Make sure you have arrows on your graph. And there's my stretch. Okay. Next one, 2/3. That's a shrink. Be careful with the fractions though, because if it's an improper fraction, then it's actually a stretch. But this is 2/3 is less than 1, so this is a shrink. This is not left, but to the right 2. And this is down 4. Okay, so I'm going to give my reference on the parent function, my little dots. I'm going to use a different color to graph my transform function. So I'm going to take my 0, 0 and I'm going to move it down 4 units. 1, 2, 3, 4. I'm going to move it to the right 2 units. And I'm going to place my new vertex right there. And from that vertex, I'm going to use my slope of 2/3. So I'm going to rise 1, 2, and I'm going to run 1, 2, 3. Rise 2, run 3. It was 2/3, so I can go up 2 and left 3. Up 2 and left 3. And if you use that reference, like this would be my axis of symmetry, you can see that these dots are the same distance away from that line, and so are those. Okay, so either way, however you want to do it. And then we draw our rays and put arrows. Okay, so that is the graph of y equals 2/3 times the absolute value of x minus 2, and then subtract 4 from that. A lot better than making a table and doing all those calculations. We will do one more. Y equals -4/3 times the absolute value of x minus 1 plus 2. We want to quickly graph this. Well, first of all, I'm going to graph the parent function. And then I'm going to figure out where is this thing moving on the coordinate plane. Well, I know I'm upside down. So that's my reflect. 4/3. 4/3. There's my improper fraction. That is not a shrink. That's a stretch because that's a number bigger than 1, right? That's 1 1/3. Okay, so be careful with fractions that are improper. You think it's a shrink, but it's really a stretch. This -1 on the inside means move to the right 1. And this +2 means move up 2. Okay, now remember, you're moving that vertex, that 0, 0 point, with these. And then you're using the slope to help you with the, if this thing is upside down, right side up, and the stretching and shrinking. Okay, so from 0, 0, I'm going to move up 2 and to the right 1. So there is my new vertex. Now I'm going to use the slope. I'm going to go down 4 and to the right 3. You can't go negative, negative, okay? So this is either down 4 and to the right 3, or up 4 and to the left 3. But we know this thing is going to be upside down, so I'm not going to go up 4 and to the left 3. Up 4 and to the left 3 would put me over here, and that's kind of weird. I know this thing is going to go upside down, so I'm going to pull the negative right there. So it's down 1, 2, 3, 4 to the right, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3 to find that corresponding point. Again, if you use the axis of symmetry, this point is 3 units to the right, and this point is 3 units to the left. 1, 2, 3, 4, 1, 2, 3, and I have my graph. And it is wider. Oops, that wasn't very good. I would turn my paper if I was doing this, and I don't want to do that in the video. Okay, so again, bringing it all together, what do you do first? I would move the vertex using these. Do your horizontal and your vertical shifting first, and then use this as the slope. The assignment is on the Schoology calendar. If you have any questions, please ask either on the homework discussion or in class. Have a great day.